Welcome back to Chemistry Exams Prep. This is Dr. Kulbhushan. We have a new question. This question was asked in last year's joint entrance exam for engineering admissions in India. In this question, we need to figure out the identities of the major products Q, R, and S. So in this question, we have a starting compound styrene, and it undergoes a bunch of reactions, the transformations, and we need to figure out the products of those reactions. So this question is not a lot of concept based question, but the memory based. So in this question, if you don't know what styrene is, the structure, you may have difficulty solving this problem. So this is something that that's why you need to remember the common names and their structures of several organic compounds. There is just no other way to solve these things. So the styrene molecule is a benzene, and it's a substituted benzene where one hydrogen is substituted by a vinyl group. Styrene is a precursor of a polymer polystyrene. It's probably most well-known reaction. So the styrene here is undergoing a two-step process. This is known as the Brown's Hydroboration-Oxidation reaction. So this reaction is a hydration of alkene reaction, which gives us overall alcohol group. And the important feature of this Brown's hydroboration oxidation is that the product is anti-Markovnikov's. So the anti-Markovnikov's product is because the OH would be on a sterically less hindered carbon. If it were to be a usual hydration, then the product would be Markovnikov's product. So to do this type of reaction, it is the only method, well-known organic method, where you can get the anti-Markovnikov's alcohol from an alkene. So this would be Markovnikov's product. Now, so this is the identity of our intermediate product P here. Now, the next reaction is the oxidation of this alcohol intermediate product in presence of chromium trioxide and sulfuric acid. So this is a very strong oxidizing agent, and so initially, once the oxidation happens, we are not discussing the mechanisms of these reactions here, but they are important. So apparently at some point of time we will discuss the mechanisms of all these reactions. So after partial oxidation, initially the aldehyde would form, and then further oxidation would give you a carboxylic acid. The next reaction in this sequence is the reaction of a carboxylic acid with chlorine and red phosphorus. So this reaction is known as an HVZ reaction for three chemists, Hell, Volhard, and Zielinski. So in this reaction, the carboxylic acid undergoes a transformation where alpha hydrogen, 1 alpha H of the carboxylic acid, is substituted by a halogen group. So in this case, chlorination would take place. Chlorination would occur, and so this is the identity of our intermediate compound Q there. So now we can see the choices here, and at this point it would help us to eliminate some choices so that we can answer this question quickly, because time is of essence there in the exam. So you have to finish very lengthy exam. So let's see the choices here. So any choice here, we have 4 choices, A, B, C and D, which does not have this as our compound Q, then we can eliminate those choices. So choice A, the Q is correct. Choice B, Q is also the correctly drawn there. In choice C here, it's incorrect, so we can quickly eliminate choice C there. Same way we can eliminate D, as this is not the correct structure of intermediate compound Q there. So now to help us to get to the identity of R and S, we are given another reaction sequence where the compound P, which is our alcohol there, this alcohol would undergo, I'll try it here, halogenation. So SOCl2 is a very good reagent to convert alcohols to corresponding alkyl halides. So this reaction would initially give us a halogenated product. Then next is the reaction of this product with sodium cyanide, and this reaction is an SN2 reaction where our nucleophile is CN group. CN is a very strong nucleophile. So the product of this substitution reaction would be this nitrile compound. So in this way we have increased the carbon chain's length by 1 carbon. So the reaction of alkyl halides with CN, a nucleophile, is one of the methods to increase the carbon chain of our starting compound. So now the next step is the hydrolysis of a nitrile there. So the hydrolysis takes place. So initially an amide forms, but the reaction doesn't stop there at the amide, and a carboxylic acid would be the final product of this reaction there. So now the next reaction sequence is the reaction of this compound R with concentrated H2SO4. So now let's go back to our choices there. So we have eliminated choice C and D. In choice A there, the hydrolysis is incomplete, so we can remove this choice A there. The hydrolysis is complete in case of choice B there. So we got the final answer without solving the identity of S there. If you are taking the test, then you can stop there and just draw the answer as B, but you can see the next reaction what could happen in case of compound R when it undergoes reaction with concentrated H2SO4. So this is an aromatic compound. Compound R there is an aromatic compound, and we know that aromatic compounds can undergo means the benzene can undergo the sulfonation reaction. But for the sulfonation, the electrophile is not simply H2SO4, it is sulfur trioxide. So SO3 is the electrophile in case the substitution is on the benzene ring, so which is not the case here. So what would happen in the reaction of R with concentrated H2SO4? So this reaction would give us intramolecular electrophilic substitution, and the product S is the product of that intramolecular EAS reaction.